In this video, let's try to understand what are the major three things a pre-trained LLM model contains. The major three things are, the first thing is it contains a vocabulary of tokens. What we're going to do is we are going to see what it is and then explain more in more detail. We will download we will load a small LLM model and then see each of those things. But let's first understand the theory here. So it contains a vocabulary of tokens, and it is actually named as vocabulary of tokens itself. And what that vocabulary is, how much number of tokens it has, it all depends on different models. For example, ChatGPT has 300 to 400 thousand unique tokens. So first thing you need to understand is it contains a vocabulary of tokens, and we will see what this vocabulary of token means and details about it. The second thing it has is an embedding matrix. So again, as the name suggests, it is a matrix and it contains some numbers, and how big the matrix is, how long the matrix is, all those depends upon different types of models. So again, we will check one of the model, what is this embedding matrix and how is it being used. And last one is something called as learned weighted matrix. This is something that LLM learns as part of the training process, and it actually automatically builds, and it is represented as WQ, WK and WV. Now we will come to that learned weighted matrix a little later, because this is a concept of the transformer based LLM models. So we'll come to that later, but first let's talk about the vocabulary of tokens and the embedding matrix. So for you to try out a model, a pre-trained model, these two lines of code is more than enough. So and this is actually downloading from the Hugging Face. Okay, so from transformers, import auto model for casual LM, and then this particular line of code is going to load the tiny llama, which is having 1.1 billion parameters, pretty small. And once you download this model, it always, I'm using Linux, so in the Linux, this is the place where you will be able to see this model downloaded. So let's go back to the code and then see how this actually works, and then let's also see what is the vocabulary of tokens it has and how many number of tokens this has. Okay, so let's go ahead back to here. So in my lab, the first one is the load model. As you can see here, I have this transformer import, and then I have this model assigned to the model, which is auto model for casual LM from the pre-trained models, and I told tiny llama is the model I want. Okay, so this piece of code is going to load the download the LLM. So let's go here, lab environment. I think we should go for 2. So this is where I'm actually loading the model, and there is a function called app.py, which is this one. I'm actually running it. And this process is going to download the LLM models, and it actually prints a bunch of details. We will see what that details are. But first thing I wanted to show you is if I go to / that particular location which I was talking about, home.cache, and then you can see there is something called Hugging Face. There is something called hub. Inside hub we have the model. Inside the model there are multiple snapshots, and this is one of the snapshot. And let's go inside that and see what we have. So we have a bunch of JSON files, right? So if you go inside one of the JSON file and then see, for example, config.json, you can see it has defined a bunch of information inside that. And one of the things that we are interested in is the vocab size. What vocab size is, if you go back to our presentation, it is nothing but the vocabulary of tokens. So this LLM model contains 32,000 32,000 tokens pre-built with it. So now, if there are 32,000 tokens, where does this token sits inside the LLM model is what we're going to see next. To understand that, let's go to the tokenizer lab. So I'm going to go back here. And let's go to my projects here. I'm going to run Python. Please note that I'm actually running in a virtual environment. Again, 3 things that you need to know for mastering and getting a job here in the network security and AI is, one thing is you need to know the coding, not at the depth of a software engineer, but at least to an extent where you will be able to write scripts. It is mandatory. It's not, you cannot escape that. Okay, so let's see the lab 3 tokenization now, and then do app.py. So let's see what is there inside that. What I'm doing is I'm importing the auto tokenizer using the same model. I am doing providing a text, and the text is the bank approved the loan, and using the tokenizer I'm actually converting this text into token and printing what the token IDs are. Okay, so let's do that. It's going to get this text and it will show you what all are the tokens that is converted. So you can see here the bank approved loan got converted into these tokens, token 450, 9124, etc, etc, etc. So what it actually does now is it converted into the token, but here is where the vocabulary of token is going to help, right? The vocabulary of token, which is inside, let's go back to our LLMs location. There is something called tokenizer.json. So if we go inside the tokenizer.json, or let's do a cat of tokenizer.json, and we'll do a pipe more. This will have the entire vocabulary. So if you come down here, let's put it a little up. You see here something called vocab inside this. This, if you see at the end, there will be 32,000 number of tokens. So these are the tokens it gets converted. Okay, now what happens is when this text is getting converted, we saw that it got converted into something 450. One of the, for example, the text the got converted into 450, right? So there will be existing in this vocabulary of tokens a token called 450. Okay, so if I search here, instead of more, when I say grep, let's say grep colon space 450 comma, you see that exact token underscore the has come. So this is where we are actually, the LLMs are actually using the vocabulary of tokens. So once again, what it did is a pre-trained LLM model contains a vocabulary of tokens. Why it needs a vocabulary of token is because when the LLM gets a text and it tries to predict the next value, it needs to tokenize this particular text. And what it does is it tokenizes in such a way that it comes to a token which is in its vocabulary, which is the nearest token, right? So there you can see there is something called underscore the. It may have THE also, but tokenizer decided to select underscore the as the token for this particular text. Okay, so first step, it contains a vocabulary of token. Why it needs vocabulary of token? Once again, when the LLM gets the text, it converts this text into smaller tokens, which is already there in the vocabulary of token. Okay, this much understood. Now let's go to the next step, embedding matrix. So what is an embedding matrix? With every LLM model, there will be a huge metric, and that metric is called as the embedding matrix. What is the relevance of this? So think of the token ID as an index to each of this row. Okay. Now you may ask me how many rows are there. I'm giving you a hint. Think of each of the think of the token ID as an index to each of this row, which means if I have, in our vocabulary we saw there are 32,000 tokens. We saw that earlier here. This particular LLM model has 32,000 tokens, and each token ID is going to be an index. You can think of it as an index to each of this row in the embedding matrix. And this embedding matrix, or you can call it a static embedding, has a meaning and a context for individual tokens. Once again, a pre-trained LLM model contains something called embedding matrix, and it has rows and columns. How many rows it has is equal to number of tokens that the vocabulary of tokens, sorry. So number of tokens, or number of the vocabulary of token that actually comes along with this LLM, that many number of rows will be there in the embedding matrix. Okay. So once again, it contains a vocabulary of token, and how many tokens this LLM, how many unique tokens this LLM has? It has 32,000. So there is 32,000 static embedding. There is 32,000 vocabulary of tokens, number of tokens for this LLM model, and there is also something called embedding matrix, which has rows and columns, and each row you can think of a token ID is referring to one of the rows in the embedding matrix. And one such row is called as embedding vector. Okay. Now what this LLM model does is, once it converts it into the tokens, which is in our lab 2 what we have seen. So what we saw when I run the lab 2 tokenizer app was it converted that text into individual tokens. Now what it does is it got a token ID. It's called as a token ID. Once it gets the token ID, what it is going to do is it goes into the embedding matrix and get the embedding vector corresponding to that particular token. That's what we are going to do in the next lab. So if I have a lab called lab 0 for embedding, I'm going to run that particular script again. So let me go back here, Python lab 04 app.py. Let's see what it shows. Oh, before that, let me take you through what the script is about as it runs, and then I'll show you the output as well. So what I'm doing here is, again, I'm loading, this is all same thing as what I have in the previous tokenization. So here I get the text, it actually tokenizes it into individual tokens. Now what I'm trying to do is, here is where the new thing comes in, right? So it is here I'm getting the input. It's called as an input embedding. So from the model I get the input embedding, and then I print the embedding layer. So you can see here, embedding layer contains 32,000 rows and 2048 columns. How many number of columns? It actually depends on the model. Also how many number of rows, it depends on the model as such. But for this model, you can see that the embedding matrix is having 32,000 rows. And the reason behind that is, as we already saw, the vocabulary of token is 32,000. Hence, the embedding matrix will have 32,000 rows as such. That's what I'm actually printing here. Coming on to the next one, what I'm doing here is the weight of it, which is 32,000 by 248. Now, The first token, you remember in our script, the earlier script, or here also, I think I'm printing here. Yeah, you can see here. So once the LLM get the text here, in this case, the bank approved the loan, it converted it into individual tokens here. Okay. And then what it does is, for each corresponding token, it goes to the embedding metric, which is looks like something like this, and fetches its embedding vector. So for this particular, token ID 450, which is the, in our case, it got the embedding matrix like this. Okay, I just print only 10, but in actual we are having a total of 2048 2048 individual numbers like this. Now this numbers is not just random numbers. This was actually done by, it has a meaning. So what it actually contains, each of this number contains, is the context of this particular word, but it is a static context, right? It's a static embedding. So it has also embedded, these numbers has also embedded the meaning that is related to each of these tokens, and tokens corresponds to this particular word. Okay, so now once it gets that, now it runs through a set of transformer steps, which we will cover later. But right now we need to understand these two things. This is pretty important. I'll take you through once again. There are three things a pre-trained LLM model contains. One is a vocabulary of token, and then it contains embedding metrics, and finally it also contains something called learned weighted metrics. But here in this video we will only talk about vocabulary of token, and we saw and this is how you get a hands-on on a pre-trained LLM model. Just 2 lines of code on Python and you get your model downloaded. In this case I'm using Tiny Llama, and from the Hugging Face is where we are downloading it, and this will be the default location where it will be having it. Once you load your pre-trained LLM model, you go to that particular place and then see the files that is downloaded. You'll be able to see something called config.json, and inside that you'll be able to see the vocab size. Vocab size is nothing but the vocabulary of tokens, the number of token that this LLM model has, number of unique tokens, by the way. Don't get confused. I'm sure you have heard about ChatGPT using trillion tokens and getting trained. But if you ask ChatGPT itself how many unique tokens that you have, it will tell that I have only 4,000 or something like that. Let's check with ChatGPT also probably sometime later. But you can see that vocabulary of tokens is already shown here, right? Now what happens once a text is being given to the LLM, it converts that text into tokens, and it fetches the token from this vocabulary of token. And then there is something called embedding matrix. Number of rows that an embedding matrix has depends on how many unique token IDs this LLM model has, right? So in our case there are 32,000, and we saw in our output that there were 32,000 rows for the embedding matrix. So once it converts the text, the bank approved the bank approved the loan, it converts into the token, and then what it does is it goes to the embedding matrix and then fetches the specific row, which we call as the embedding vector. Okay, and that for this particular Tiny Llama, it has 2048 number of columns, and what it contains, which is embedding vector, what it contains is a meaning and a context for a specific word. Now with this, so it does not only for the one token, it does the same thing for all other tokens. And after that, it goes through a set of process. which is where we will learn about WQ, WK, and WV, and that there is a matrix multiplication that actually happens in each layer to find what exactly is the context and what exactly is the user is trying to understand. We'll go deep on the learned weighted metrics later, but for this video, understand pretty deeply what a vocabulary of token is, why is it important, and what an embedding matrix is.